Hi, this is Mr. Mack. Now, we're going to talk a little bit about systems of inequalities. Now, when you see the word systems, that means to a mathematician that you have more than one equation or inequality in this case that's generating ordered pairs. An inequality that generates ordered pairs, remember, an inequality in two variables anyway, is one that has some kind of a line or curve, and then one side or the other of it is shaded. So if you have a system of inequalities, then what you're looking for is the solution to the system, or you're looking for the ordered pairs that make all of the inequalities true at the same time. Now, the way we've learned to deal with inequalities in two variables is to actually show a picture of the solution by graphing them. And the way we graph them, of course, is to find the line or the curve that is the edge, and then we decide which side to shade in. Now, let's take a look at a fairly simple system. Let's say we have y is less than or equal to 1/2 x plus 1, and with that we're also going to have y is greater than or equal to 3/2 x minus 1. And we want to know, or we want to find the solution to this system of linear inequalities. Now, the first thing that we're going to do is we're going to go ahead and graph both of these inequalities on the same axis. Now, we don't have to have just two. Sometimes there are 3 or 4 or 5 or even more inequalities that we graph on the same axis. We'll take care of that in just a minute. Okay, so first of all, let's just take a look at what this looks like. The first one, y is less than or equal to 1/2 x plus 1. What we're going to do there first, again, is we're going to think of the line that's the edge, and that's y equals 1/2 x plus 1. Well, that is a line that goes through 1 on the y-axis, and it has a slope of 1/2. So we go up 1 over 2 to get another point, and we could continue on that way. And so this would be the line that would be the edge of that half plane. Now notice I've drawn it as a solid line because the or equal to is included. And the part of this line that we would take would include 0, 0, because if we put 0, 0 into the inequality, it gives us 0 is less than or equal to 1, which is true. So we really would want to shade this side of this inequality. Now, for the second one, let's just turn this inequality red. For the second one, we would graph this one, and this one, again, the edge would be y equals 3/2 x minus 1. Here's negative 1. There's a slope of up 3 over 2, up 3 over 2, up 3 over 2. So the line for this inequality looks like this. And then again, we ask ourselves, what side of the inequality do we want to shade in? Well, again, let's try 0, 0. And if we put 0, 0 and we get 0 is greater than or equal to negative 1, and that's true. So we want this side of this line. Now, the solution to the system of inequalities is the part of the plane that's shaded both times. And it's probably easy to see this time that we're looking at this region in here. But sometimes it's not as easy to see that, especially as we put more and more and more inequalities into the system, because sometimes we'll have more than 2 or 3, and it does get a little bit more complicated. So what I'd like to show you is when you're graphing systems of inequalities, instead of actually shading each region as you solve the inequality, what I suggest that you do, extra piece there, I guess. Okay. What I suggest you do is, for example, imagine for a minute here that the red line, well, maybe we can do this. Okay. Now, once you've graphed the blue line, that is the edge of the inequality for the blue line, you check to see which side you want to shade in. And when you put 0, 0 in, you find that, yes, that does work, and so we want to shade the side that contains the origin. Just put a little arrow on the line someplace saying, this is the side we want. Now, don't shade anything in at the moment. Then you graph the line that's the edge of your next half plane, y is equal to 3/2 x minus 1. And again, you check which side of that line you want. And if you try 0, 0, you find that it's true also. So you want the side of the line, again, that contains the origin. And then finally, once you've graphed all of them, simply take a crayon or highlighter or something like this and shade in just the region that is the solution. Now, that makes it a whole lot easier to see. See, notice what we've done is we've just put little unobtrusive arrows on our lines saying this is the side we want. And then after we've done all of that, we identify the region that is the solution. So the shaded region here is the solution to that system, which is what we're really looking for. Now, there's a couple of things that need to be mentioned here, because this section is actually building up to a thing called linear programming. And what we're beginning to do is we're identifying the region where the points that are matched with that region will make all of the inequalities true. And in linear programming, we're going to call that the feasibility region. Now, the thing that ends up being important many times is what are the vertices of the feasibility region. Now, in this case, since we only had 2 inequalities, there's only one vertex, and that's this particular point right here. And so we need to perhaps identify that particular point. Now, let's change the system just a little bit, and let's go ahead and add a third inequality. How about y is greater than, and let's just leave it greater than, so we'll have dotted, negative x minus 6. Now, if we had that third region, then this shading really does need to go away at the moment. And what we'll do then is we'll graph the line that's the edge of this third one, and since it's y, the line is y is equal to negative x minus 6, we'll go through negative 6 on the y-axis, that's here, and we have a slope of negative 1, and this one's a dotted line, so our slope will go like this. Now, if you ask yourself, does 0, 0 make this one true? Yes, it does. So we want this side, we want the side that contains the origin. And now, to shade this region, we'll just keep this color here. I don't know what color crayon that is. And this is the region that is the solution of that system of 3 simultaneous linear inequalities. Now, what we may be asked to do next is to identify the vertices of the feasibility region. Now, what we'll do is we will use algebra, and we will find these points using the algebraic methods of solving systems of equalities. See, what we have for this point right here is that is the intersection of the line y equals 1/2 x plus 1 and y equals 3/2 x minus 1. So to solve this system of linear equations, probably the easiest way would be to use substitution, where I'll put 3/2 x minus 1 in for y in the first one. I get 3/2 x minus 1 equals 1/2 x plus 1. If I subtract 1/2 x from each side, I get 2/2 x, or just x, minus 1 equals 1. Add 1 to both sides, I get x equals 2. And if x equals 2, put it back in the first equation. Y is equal to 1/2 times 2 plus 1, which is also equal to 2. And so we get the ordered pair 2, 2 as that point of intersection. Now, we want to know the intersection between the blue and the red line. No, the blue and the red line we have. How about the red and the green line? See, the red and the green line would be the system y equals 3/2 x minus 1 and y equals negative x minus 6. And once again, we can use substitution here because of the way they're written. We have negative x minus 6 equals 3/2 x minus 1. And so if I subtract 3/2 x from both sides, I get negative 5/2 x minus 6 equals negative 1. If I add 6 to both sides, I get negative 5/2 x. I can do this. That's 5/2 x equals 5. And if I divide both sides, I'll just do it this way. We'll multiply by negative 2/5. I get x equals negative 2. Now, if x equals negative 2, I can put that in this equation here. For example, y equals the negative of negative 2 minus 6, which gives me negative 4. So I have the point negative 2, negative 4. And then I have one more point to find. That's the intersection of the blue and the green line. So let's erase this. And we'll go back and find the intersection of the blue and the green line. Now that system is y equals 1/2 x plus 1 and y equals negative x minus 6. And to do this, once again, substitution, negative x minus 6 equals 1/2 x plus 1, plus 1, there we go. If I subtract 1/2 x from each side, I get negative 3/2 x minus 6 equals 1. Add 6 to both sides, I get negative 3/2 x equals 7. Multiply both sides by negative 2/3. And I get x equals negative 14/3. And so if I put that back in the first equation, I get y equals 1/2 times negative 14/3 plus 1. And I can cancel here, get negative 7. So I get negative 7/3 plus 1, which is negative 4/3. So this is the point, negative 14/3, negative 4/3. Now, when we get to the next section and do linear programming, the vertex points of the solution to the system of inequalities are going to be supremely important, because that's where we're going to find our optimal points. But for right now, as you're doing these problems, the directions are simply going to say find the vertices of the region that is the solution to the system. And so you can use algebraic means. Now you can also use your calculator with these equations that are on the edge. And you'll be seeing me do that on some of the solution videos, so you should be fine there. Now there's one more thing I will mention. There are times when a system of linear inequalities has no solution as well. Let's just take a look quickly. If you had, for example, and I'm not even going to come up with equations. Let's say, for example, you had a dotted line here, and this was the side you wanted to shade. That was one of the half planes. And then another one of the half planes, you had, say, a solid line here that was parallel to that line, and this is the side you wanted to shade. The solution would not exist because there's no overlap between these two half planes. So it is possible to have no solution to a system. And if you have more than two linear inequalities, you could even have something where maybe there is an overlap between any particular two of them. Like notice this blue region and this red region do overlap, and let's say you had a third region that was here and this was the side you wanted to shade. There's no overlap between all three of the regions, even though pairwise they do overlap. So there are a number of different ways that you can have no solution to a system of simultaneous linear inequalities. All right, well, have fun with these, and we're done.